This is section 4.0, and we're looking at theorem 4.0.2. And what this theorem says, in a nutshell, is triangular matrices. Now, they say I less than j, so we'll have to look, is that an upper triangular or is that a lower triangular? So think about that. But if we can do it for one, we can do it for the other. So they say for this theorem, let A be the matrix made of these components Aij, where Aij is equal to 0 if I is less than j. Now, what is that? So you could have things like, 1 is less than 2. So where is that? Is that above the diagonal or below the diagonal? Well, it's row 1, column 2. That's above the diagonal. So this is saying that we have a lower triangular matrix. Okay, because everything above the diagonal is 0. And so we'll just say this is a lower triangular matrix. And so if this is the case, we have that the determinant of A is just the product of its diagonal. So A11 times A22 all the way to ANN. So that's pretty cool. And so in particular, a diagonal matrix is lower triangular. And so for a diagonal matrix, you would just multiply the items in the diagonal. And so here they say, okay, they have a proof, and it's by induction. So, it seems like, yeah, if we're going to do induction, probably we want to start with n equals 2, and that's what they do. So, for n equal 2, what we're talking about is that A would equal A11, 0, A12, A21. Try to get that right here. A21 and A22. So it looks like that, and certainly if I take that determinant, it is just determinant of A is A11, A22 minus 0. So it is indeed the product of the diagonal. Okay, and so now we assume true for size, n minus 1 or less. Okay, and so now we look at an n by n matrix. So we let A be an n by n matrix, which would be A11, A22. We got a bunch of zeros up there, ANN, and A21, and fill all this stuff in down there. Okay, but then what we know is, in this case, since these are all zeros up here, when we take the determinant of A, that's A11 times the minor 11 of A. And and that's it, because everything else will be zeros, right? So that would be minus 0 times m 1, 2 of a, and so forth, all zeros, right? So those are gone. But then this, by our induction hypothesis, that minor here is just the determinant of that, so that's A11 times, by our induction hypothesis, A22, A33, dot, 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 to ANN. And so there we go. So by induction, we have it. Okay, so that was nice. And now, upper triangular, it's also true. But again, we need a little something to help us, okay? Because, right, if we go to an upper triangular, the problem is that top row is not a bunch of zeros, okay? So as you can tell by some of these things, since it's also true, when we do stuff for rows and then we say it's also true for columns, yeah, probably there's a really nice theorem involving transposes or something along those lines. Wouldn't you think? Right? So anyway, that is theorem 4.0.2, I think that was, right? And so that takes care of that one, I think.